Today is a day that we're gonna do some stuff, I guess. All right, 2.7, related rates. Okay, related rates are, you guys struggle with them for two different reasons, and neither of which are a very noteworthy reason to struggle. One, you guys are awful at word problems, and I don't understand why, because you, in theory, have been reading since you were like 4.
Defining your variables and all that.
You hope, whatever. The second thing is that you guys forget basic geometric formulas, like volume of a sphere, right? Volume of a cylinder, surface area of these things. If you guys are like, I don't remember any of those, you're gonna have a bad time. Okay, here is the idea. All right, so if, for example, okay, if we had a cone, right? A cone looks like this, do we agree? Okay, the radius is here. This entire piece here is our height. Okay, do you guys remember how to take or how to find the volume of a cone? Vincent?
Isn't it, we find the area of the circle and then multiply that times the height?
Correct, but there's a piece to it because if I did that, that would be a cylinder because I'd have the area.
It's 1/3.
It's 1/3 of that, right? So the idea here is the volume equals pi over 3 r squared h. Now, to be clear, right? Pi r squared, area of a circle, times the height would give me the volume of a cylinder, but it's 1/3, so that's how we're gonna write this. Now, the idea of related rates is we're gonna take the derivative now, but a lot of times what we're gonna do is we're gonna take the derivative with respect to time. So what we're gonna do is take the derivative with respect to time on both sides. Time. You know, like the fourth dimension. So, what is the derivative of v with respect to t? dv over dt, right? It's v prime. Does that make sense? Okay. Yeah. Guys, it's the same thing as me taking the derivative of y with respect to x. The variables don't match, so you have to take it becomes dv dt. Because realistically, what is the derivative of v? 1. But we have to chain rule it because my variables don't match, so it becomes dv dt. On the right-hand side, what rule do we have to use? Product rule, right? So that pi over 3 is just a constant that I'm going to pull out front. You guys with me? But now, what we need to do is use our product rule, right? Of r squared and h. Does that make sense? Okay, what is the derivative of h with respect to t? dh dt. And that's still times r squared, correct? Plus, what is the derivative of r squared? 2r. Derivative of r with respect to t? dr dt. And then that still has that times that h there. Does that make sense? Because all we're doing is product rule. Well, I was showing that we were taking the derivative of r squared times h. I can reorganize it.
Oh, so I get it. Yeah.
Why is our first one times dh dt and then the second one's dr dt?
Okay, so the first one is I am taking the derivative of h. What's the derivative of h? dh dt times r squared, because that's our product rule.
Yeah.
Right? Remember, it's f prime times g plus g primes times f.
Okay.
So this is this derivative. This is r squared's derivative. So we get dv dt equals pi over 3 times right? I'm probably going to write this a little differently. R squared dH dt plus 2HR dr dt. Okay. Is this, you guys kind of see what we're going to be doing? Now, let's think about this. What does dV dt represent? I don't want to hear the word derivative. What does this represent contextually?
The accelerated change of the volume.
The change of our volume with respect to time.
Okay.
What does dH dt then represent?
The change.
The change in height with respect to time. What does dr dt represent? The change of the radius with respect to time. Does that make sense? Are you guys kind of with me? So now what we're going to start doing is we're going to have these word problems, right? And we have to decipher. They're going to give us rates of change. And I'm going to have to say, hey, are they talking about my change of radius? Are they talking about the change of the height? Are they talking about the change of the volume? Does that kind of make sense? Okay, let's start with an easier one. Okay. So we are saying the variables x and y are both differentiable functions of t and are related by the equation y equals x squared plus 3. We want to find dy dt when x equals 1 given dx dt equals 2 when x equals 1. Now, we're starting off with a pretty basic example. It doesn't have a whole lot of information for us to have to go through and decipher, okay? Just so we can kind of get the process. If you guys can't tell, this whole chapter has been very process focused, right? Chapter 3 is when we really can start figuring out the importance of derivatives and what they tell us about things. So really 2.7 is kind of our first venture into that realm. Okay. So, what do you guys think we're going to start with? We're going to start with y equals x squared plus 3. Okay, what is it that we want to find? We want to find dy dt. What does this represent? The change in y with respect to t. So what are we going to derive with respect to? T. So we are going to derive both sides with respect to t. Okay, what is the derivative of y with respect to t? dy dt. What is the derivative of x squared with respect to t? 2x dx dt. And what is the derivative of 3? 0. Right? It's a constant. Okay.
Why do you do that? This was like this dy and dx.
Okay. Here's the idea. What is the derivative of x squared?
2x.
2x. Does t and x match?
No.
So then I have to chain rule. What's the derivative of x with respect to t? dx dt. Right? It's the whole, it's us doing the, it's 2,5.
So you can just change it?
We're not changing it. It's because if this was with respect to x, you're right, it would just be 2x. but it's not, it's with respect to t. So I have to chain rule it, so x squared is 2x, but then the inside part is x. What's the derivative of x with respect to t? Dx
And
dt.
y is equal to 1, but we still have this.
Y is 1.
So that's dy over dt times 1.
Correct. Okay, now, they told us what some things equal. They told us what dx dt equals. And they told us what x equals. We literally just substitute those things in. So dy dt equals 2 times 1 times 2, which equals 4. Like I said, we struggle with this because we struggle with word problems. And I'm not an English teacher. Okay, are we okay? All right, let's go into context now.
No.
I know some of you guys, you probably want to write this down or not. It's up to you. I'll give you guys a minute or two.
I'm using that a little bit.
Okay. So here's the idea. A pebble dropped into a pond, causing ripples that form concentric circles. And then I'll show you guys the little picture. It's literally just water rippling. We've all seen water rippling, correct? Okay. The radius r of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of the disturbed water changing? I'm going to give you guys a minute or two to write this down. I'm going to tell you, we basically have like 5 examples, and that's all that we're doing today, potentially. And I'm not assigning you guys homework today because Thursday and Friday are us practicing this a lot.
And tomorrow the juniors have nothing.
I know the juniors have a 430 factoring packet. No. Although looking through your tests, you guys still can't factor. Yes.
I don't know what compound is. All I know is like, I just look at it and my brain starts splitting numbers. Remember like there's one type of thing where it's like, you'll have like 6 over 9 or something like that, because both of them can be reduced by the same number, you reduce them and equal out. So like factoring is weird, like, I've gotten into like, I'll factor it, and then like, just to make sure I actually factor it right, I'll read it right, so that I can make sure it's
No, I just
I really don't get it. I get it I know how to do it. Well, now I actually have to. It's not bad. I write. It's just not bad.
Are we still writing? Hi, JD. Thanks for being here today. I'm way back. Just. I mean, you're fine. It's okay. I'm pretty sure I'm going to be getting sick from going to camp this last weekend for student council. Brandon. He's patient 0.
It was Brandon, 'cause we-
Okay. Listen. I feel like I wish I was Dumbledore. Silence. Just really loud. Okay.
Can you get a megaphone? Oh, Mr. Mello has a mini megaphone you can borrow.
Should I call Jay and bring the Aztec?
All right, this is kind of what the picture looks like. I figure we've all seen a pond rippling before, yeah? You've never thrown a rock into a pond? Okay. Here's the idea. We're going to start. Hey, listen, we are going to start with labeling 3 things every time we're doing these problems, okay? We're going to start with the equation. Okay, what equation are we going to have to use here? Area of a circle. What is the area of a circle? Pi r squared. Okay, the next thing that we're going to label specifically is the given rate. Okay, what is the rate that they have given us? 1 foot per second. Do we agree? Okay, but what does that mean? Like, what is that? What is changing at a rate of 1 foot per second? The radius. So did they give us the radius or did they give us something else? They gave us dr dt, right? I'm not going to say r equals 1 foot per second. Do we agree? What they gave us is the change of the radius with respect to time. Does that kind of make sense? Okay?
Time part, I think the radius, I mean, I don't even know what I'm gonna
1 foot per second.
Per second.
do. We have one radius thingy.
No, it's changing at a rate of 1 foot per second.
Yeah.
Seconds is
The
unit of
R is
time.
the radius. The D
Yes.
So ddt would be acceleration.
What's that? Guys, why are we stop?
Wouldn't, like, if, like, acceleration with respect to x, wouldn't that be accelerate? Velocity with respect to
Okay,
x, wouldn't that be
I like that you're working on making that connection.
Read the
Let's hold
last
off on
question
that.
again, the last sentence. What is it?
Okay, the last piece. What do we want to find? At what rate is the area? So what we want to find is dA dt when what?
Radius is
When r equals 4. So if you can come up with this, right, it makes your life far easier. Right? Being able to identify, hey, what equation am I going to need? Okay? What's the given rate that they're given? Because right now they're only giving us 1 rate. I'm going to tell you that we're going to work on stuff where you're given 2 or 3 rates. Because think, guys, area, right? Area of a circle is only related to r, right? What about volume of a sphere? Right? What about volume of a cylinder? Okay, those things can be related to multiple different pieces. Okay, so where do you think that we're going to start then? So we have A equals pi r squared. What am I going to derive with respect to? Time. So d dt. What is the derivative of A with respect to time? dA dt. Okay, remember pi is just a constant. Do we agree? So I'm just going to keep pi. What is the derivative of
Why do you make it 0?
what? No, it's a constant. It's multiplying. If it was plus pi, it would be 0. Remember, guys, if I have something like 3x squared, what's that derivative? 6x. The 3's not 0.
Oh, yeah, I know what you're saying.
Okay, what is the derivative of r squared? And then with respect to t, dr dt.
We have drt.
Yep. So now, right, now we have to look at, okay, well, what information did they give us? Oh, they gave us dr dt. So we're going to substitute that in. And, right, they gave us r. So we're going to substitute that in. Does that make sense? So we get 2 pi times our r of 4 times dr dt is 1, which tells us
DADT is equivalent to
8 pi. Okay, now we're talking about area, right? So it's feet squared or square feet per second. The labeling is important, right? Because that's that context piece for us. That's it. Does that kind of make sense? If you guys can tell, this is going to be, we're going to practice this a lot. Why is this a good thing for us to practice a lot? 1, it helps ensure that we know what our derivative rules are. 2, it allows us to practice implicit differentiation. 3, it allows us to work on word problems because you guys are taking the AP test, and we all know that College Board is notoriously wordy, right? They're very verbose in all of their questions. Okay.
I really thought I was good.
So guidelines for solving related rates.
Is this gonna be like a big chunk of writing or a small chunk of writing?
I don't know, it's like,
So I have a little bit of occasion.
I would probably flip it then. The first thing, identify all given quantities. And quantities to be determined. Make a sketch. So this is arguably going to be one of the more important things for you to do, right? Identify all your given quantities, figure out what you need to find, and then make a sketch. Because for a lot of us, right, as soon as we turn words into a picture, it becomes a whole lot easier for us to visualize what's going on. Yes?
All given quantities and quantities?
Quantities to be
And
determined.
Quantities TBD, to be determined. So the things that we're looking for. Okay. The second thing, right, is write an equation involving the variables Savannah, were you able to figure it out? Yeah. Okay.
That's my breakfast.
What is that word?
Which implicitly,
I just didn't understand you right.
we wrote it 2.5.
Are we gonna get problems where there's like
Oh, 100%.
What'd you say? I wanna know what's 100%.
I just keep making things up as I go.
also like Sergio?
As we get to the higher levels, we can just start making up the lower levels, so using the higher levels. They just make it up.
Okay, if you guys can't tell, there's a reason I highlighted after step 3. If you start substituting beforehand, right, it's gonna change what your derivative is and it's gonna be wrong. So if you guys notice, we didn't substitute 4 in for r squared in that last value and then take the derivative. You differentiate and then substitute everything in.
Because then it would be a constant.
Because then it becomes a constant. Does that make sense? You guys with me? Do we all have this written down or are we still writing? You guys are so chatty today.
Well, like after yesterday where it's all sitting single file.
It is because you put it back in.
I didn't put them back in, they did.
You gave us the ability to do it ourselves.
Oh, hold on. Let's do this other one first. Okay. Air is being pumped into a spherical balloon. Spherical? You've never seen that word? All right, air is being pumped into a spherical balloon at a rate of 4.5 cubic feet per minute. Find the rate of change of the radius when the radius is 1 foot. Okay. What is the first thing that we do? The equation? Oh, sorry, what's that?
I was just gonna say we should write down.
Yeah, here's the deal, dude. Whatever way works for you, right? Some of us will be like, hey, let's start with the equation. Some of us are going to say, hey, I do better when we write down my given information, right? Whatever way works for you. I'm not going to look for it a specific way. We need these three things, right? So if we start with our given rate, what rate did they give us? So I'm going to write that as a fraction, which is 9/2. Are we okay with that? So 9/2 cubic feet per minute. What rate of change does that represent?
Volume over,
How do we know it's volume?
because it's cubic.
Because it's cubic feet. So this is dV dt. Does that make sense? Things that we also need to check and understand. Sometimes they give us our rate of change per minute and then later ask for it in seconds. So we really need to pay attention, okay, to the labels and the units that are given to us. Okay, what's equation are we going to then use? Volume of a sphere, which is what?
4/3 pi r cubed.
4/3 pi r cubed. Okay, and what is it that we want to find? The dr dt when r equals 1. Okay, we have our given rate, we have our equation, we know what we need to find. Are we good to get started then? Are there any questions on where this information is coming from? Okay. So, if we differentiate with respect to t, what is v? What's the derivative of v with respect to t? dv dt equals, do we all agree 4/3 pi is just a constant? So I'm going to pull that out. What is the derivative of r cubed? 3r squared. Now we need to incorporate the respect to t piece, dr dt. You guys with me? Okay. Now, if it's me, right? I was like, some of you guys are like, I'm going to plug here and then I'm going to go. If it's me, what I'm going to do is I'm going to actually solve for dr dt and then substitute my values in. Okay? So what do we do to solve? Well, first off, those 2 3s cancel, right? So then I'm going to divide both sides by what? 4 pi r squared. Because I'm solving for dr dt. Remember, guys, we want to solve for dr dt. Which part? No, so guys, I have 4 pi r squared dr dt. What operation's happening here? What's the inverse multiplication? So I'm going to divide both sides by 4 pi r squared because I'm solving for dr dt. So we get dv dt, right, times 1 over 4 pi r squared equals dr dt.
And we know,
Correct, because that's what we want to find.
and we know dv dt.
And now we go up, say, hey, we know what dv dt is. And we know what r is. Right? At this point is where now we just plug and chug. So we get dr dt equals, what's dv dt? 9/2 times 1 over 4 pi times 1 squared. At this point is where you plug this into your calculator. Okay, the AP exam expects 3 decimal places correctly.
And it would be,
We can't just leave it in high, like at the bottom. Wait, they want you to, oh, wait, never mind. Wait, no,
What does that equal? What, 0.358? Okay, what's our label?
Yeah, I got 3.5.
I did not do that.
I got 3.5. Where's the cubic go? It should be 9/85.
Well, it's 18. Yeah, I just have to- that's what I read. How could it
Right,
be?
it's 9/2.
I got 3.513.
Don't do that. No, because you wrote it down like that, you got a different answer.
Well, I don't know what he did.
I got 0.358, guys.
That's not what I
Yeah,
got.
that lines up, because
you
you're plugging
put
it
it wrong,
into
you
the
didn't put
calculator
parentheses.
wrong.
It's the parentheses, they don't.
I did not write it that way.
9.
Yeah, I did it both. Listen, I was like, I did it both ways. Do you guys know how to use a fraction on your calculator? You hit alpha x and the fraction thing pops up. Okay, cool. Foot per minute, feet per minute, something. Okay, questions on this? Are we doing okay? What are our questions? Did we all get 0.358 now? Okay, do I have any questions? All right, do this one on your own then. Would you like me to draw the picture for you? Or would you like to draw the picture yourself?
I'd like you to draw.
That's our radio station. Here's our airplane.
I've never seen a stick figure. Oh.
So when you read the problem, you'll understand why the sides are labeled that way. That's an S, not a 5, before anybody complains about it.
did we see the full problem?
All right, go team, go. Have fun.
Really, like, the only part that's like that important is the triangle.
How did you get 6 and 5?
Oh, it's an S that I said specifically from.
You need to draw.
Yeah, where did I get 6 from? I expect you guys to try.
Ignore the 6 for now.
Just make it another value, make it a lie. It's not real.
Hey, let's make a fire.
That is not.
Luke will no longer be able to sell his notebook to some underclassmen at the end of the year. I know that like that's typically top of my list. When s equals 10, so if s equals 10, you know, using the Pythagorean theorem, we can get that 100 minus 36 equals 64, or x equals 64. So x squared equals 64. Square root of 64 is 8, x equals 8.
Well, what's your radius?
What's 100 minus 36? What's 100 minus 6? 100 minus 6.
Try that.
I literally don't understand what that number is.
Try that.
I don't know. It's just a I just know that x equals 4. What that actually does with anything is to be determined, but x equals 4. It has to be. When s equals
Yeah, well, that's why this stuff easy with S. What is the spill?
Anybody figure out where the 6 came from yet?
It came from like you actually It's like
What
actually real.
hypotenuse? I don't know.
Well, it's a right triangle. What's your hypotenuse?
Oh, you a squared plus b squared did it.
Okay, what's your hypotenuse?
400.
10. S is 10. Right? So what kind of right triangle would we want? A Pythagorean triple. 3, 4, 5, 6, 8, 10.
Yep. I mean, that's what I've been saying. I just don't know where to take the next step on that.
So what would X then be?
Oh, it would be
Thank you, Luke.
In other words, velocity is displacement.
Velocity is total.
Pythagorean triples.
Over the total time you spent to travel that distance.
You guys didn't talk about them at all in pre-calc? Because you should cover them in geometry. So there's Pythagorean triples are
We did cover them last year.
so you have 3, 4, 5s,
We did.
right? Which means
We talked a lot about 3, 4, 5,
3,
and the double.
4, 5,
Maybe for like
and that, like I could double it, triple it. It's always going to be the same size ratios.
Yeah, it's ratios of side lengths.
There's a 5, 12, 13.
Yeah, we did discuss this.
Okay.
We
Well,
probably
we could
didn't discuss
revisit those at
this
some
in depth
point.
or in depth, but we definitely went over this. Because I know this isn't the first time I've seen this, when it's like, what is it, like a long right triangle?
Okay. So what given rate do they give what given do they have?
Well, it's like one is like 2x, two is like 3.
Well, they tell us the distance S is decreasing at a rate, right? So ds dt equals what? Negative 400 miles per hour when S equals 10. What do they want us to find? Okay, so they want us to find dx dt. Correct? When S equals 10, and what does x equal? 8. What?
Why do we do dx instead of ds?
X is the horizontal distance. S is the distance between the plane and the actual radio station.
The triple Pythagorean theorem.
Triple?
Yeah.
Yeah. Okay. All right, what equation are we going to use?
Speed equals distance over time.
What shape do we have? There we go. X squared plus 6 squared equals S squared. This is the issue. I cannot plug in 100 for S first. I need to differentiate first. What are we going to take the derivative with respect to? T. What is the derivative of x squared with respect to t? 2x dx dt. What is the derivative of 6 squared with respect to t? 0. Equals, what is the derivative of s squared with respect to t? 2s ds dt. What is it that we are trying to solve for? dx dt. Okay, so we're going to divide both sides by 2x. So dx dt equals s over x ds dt. Do we agree? I'm solving for dx dt. So I'm dividing both sides by 2x. Okay. Now we have everything we need to plug it in, correct? Do we agree? S is 10. X is 8. And what is ds dt? Negative 400 miles per hour. Okay, what does this end up becoming? What's negative 400 divided by 8, guys? Negative 50 times 10. This is negative 500, right? Miles per hour. Do we agree? However, this is the velocity. The question was asking us the speed. Speed is different than velocity, correct? Because velocity is factoring in your position. So if my velocity is negative 500 miles per hour, what's the actual speed of the plane? Just 500 miles per hour, right? The speed's not going to be negative. Does that make sense? Okay, are we all good there? Living our best lives? Okay. We good? Solid.
You're hunk. How about that?
You guys are being nice that I'm giving you pictures day one. Savannah and Taven didn't get pictures day one. They had to draw them. And then everything looked like a penis for a while.
Yeah.
Do you remember Christian? Everything. Yeah. Every picture I drew ended up being turned into a penis somehow.
You have, see, it takes a creative mind.
Okay, so here's the idea. A television camera at ground level. You guys notice how it's recessed, so I'm saying it's in ground level. Okay, is filming the liftoff of a rocket that is rising vertically according to the position equation S equals 50t squared, where S is measured in feet and T is measured in seconds. The camera is 2,000 feet from the launch pad. The actual question is, okay? The actual question, okay, is find the rate of change of, or in, there we go, in the angle of elevation of the camera at 10 seconds after liftoff. So typically what will happen, guys, is that you're not even going to be given this picture or this equation. You're going to be given this, an actual question, and that's it. That's why we're going to be practicing this Thursday and Friday. Okay? I'm going to give you guys some time. Work on it on your own. Slash together.
So, should we ask, as is our height by the diagram, should we try and figure out like the height when S equals, or when T equals 10?
Did this end up working out?
He also, we're not do that to figure out our last step.
Writing the whole
Why?
So
I just mean like, I don't really feel like writing down the whole thing, and we could just look at it. Is that beneficial?
Yeah, but we're gonna have to look at my notes after.
This is true, this is true. You have me beat this. I cannot digress with that.
I'm not gonna look at the random equation and then be like, what was the root?
Ah, of course.
before finding the angle.
But you can have 6 squared. Six.
Call up on your hand and put it on somebody's computer.
That's actually.
We're finding the angle, we're not gonna be
How many people you think touch their computers a day?
tangent of
A dozen. More?
Really gotta start stapling your stuff.
Yeah.
Oh, it's not supposed to be a turn shit in. I don't understand. Like, I feel like the numbering system's very clear. Turn into the basket that corresponds to your period. And yet, like, 3 of my classes can't figure this shit out.
It's like at the beginning of every school.
We're a month and a half in. We're not the beginning of the year anymore. Also, if you walk to the back and you're like, what are these numbers? Like, we figure it out?
Oh, yeah.
Need another couple minutes?
I don't even know like what you have to use.
Not working again. What's up? Oh, gotcha.
So I wonder, tangent, that's just our equation. The tangent theta equals S over.
2x squared minus 6x.
Yeah.
There you go. I didn't think that was the part that was gonna get us. Okay, couple things. Okay, so first things first. They gave us tangent theta equals S over 2000. Do we all see how they got that? We're good there. Okay, couple things that we can figure out, right? They give us a given rate. Can I move off of this page?
Yeah.
Okay, the given rate that they give us was ds dt. What did they tell us that was?
50t squared.
Okay, sorry, so they gave us S equals 50t squared. So we could find ds dt by taking the derivative with respect to t on both sides. What's the derivative of 50t squared? 100t. And the variable matches, so there's not dt there, right? Does that make sense? Okay, that is a given thing they gave us. What else did they give us?
DSDT, which is 10.
Hold on, say that again. I just didn't hear.
DSDT is 10.
Where are you getting? You're saying t.
T is 10.
Okay, you're right. They're telling us when t is 10. What can I find knowing t is 10? The actual height. I can find the height of the rocket at 10 seconds. Right? How would I find the height of the rocket? Not into the derivative, into the original function. We'd plug in 10 here, right? So the height when t equals 10 is 5,000 feet. You guys with me? What does this represent on our picture? It's the height of the rocket, correct? Okay. You guys with me? Okay. So what we're looking for, okay, what we want to find, okay, is we want to find d theta dt when t equals 10 and s equals 5,000. So that's just, 10 seconds and s is 5,000 feet. Does this make sense?
Wait, D what? DQ? DL?
D theta. Because we want the angle of elevation. You guys with me? This isn't 10 raised to a power. It was me not labeling it. 10 seconds. Okay, what equation did we know? Tangent theta equals what? S over 2,000. That is the equation that we got from that triangle. Do we agree?
Yep.
So we need to take the derivative with respect to what? T. Every time, right? d, t. Okay. What is the derivative of tangent theta? Secant squared theta. And now, what is the derivative of theta with respect to t? D theta dt equals 1 over 2,000. What is the derivative of s with respect to t? Just ds dt, right?
How is it 1?
How's what 1?
1 over 2,000.
I just pulled, if I'm dividing by 2,000, that's the same thing as 1 over 2,000. I just pulled the 2,000 out.
I know, but
It's not a 5, it's an S.
oh, I'm sorry.
Okay. Now, if we are going to solve for d theta dt, how do I do that? So we get d theta dt equals 1 over 2,000. Really quick, what is 1 over secant squared? It's just cosine squared. Theta times, what is ds dt? 100t. So, hold on. So guys, I divided by secant squared. When you're, if I had secant squared in the denominator, that's just cosine squared. You guys with me? Okay, I replaced ds dt with 100t because we found that earlier. Okay, do we know what to plug in?
So GSDT equals 100?
Okay, so we know d theta dt equals 1 over 2,000 times 100 times what? 100 times 10. Okay. Now, your issue here is cosine squared, theta, right?
Evaluate for theta using the formula for tangent of theta.
Guys, we have a picture here. Could you find cosine theta squared?
Adjacent over hypotenuse, so it would be 2,000 over 11 over 8. Never mind.
Adjacent over hypotenuse.
No, 2005, they got the calc. No, that's the tangent. What? 2005. Adjacent over hypotenuse.
Okay, what's your adjacent?
2,000,
What's your hypotenuse?
5,000. Nope. That's why I just found that I don't have mine.
No, you gotta do a squared plus b squared. You gotta do 2,000 squared plus 5,000 squared equals, whatever plus squared. And then, yeah.
Right? Put using Pythagorean theorem. Ugh. Okay, so what is cosine squared then? 2,000, right? Over what? What was S?
50t squared.
Squared plus 2,000 squared.
We have to square root that, or is that just like that?
Well, remember it's cosine squared. Well, it was cosine squared. So doesn't that squared get rid of that root? Sorry, that should be squared, that one. Okay, listen, guys. Cosine of theta is 2,000 over the square root of s squared plus 2,000 squared. Do we agree?
Yeah.
But I wasn't looking for cosine, I was looking for cosine squared. So if I square this and I square this, what do we get?
2,000
2,000 squared over S squared plus 2,000 squared. And S is 5,000. Now a couple things happen here, right? One of these 2,000s simplify here. Do we agree? Right? D theta dt equals 100 times 10 times 2,000 over what, 5,000 squared plus 2,000 squared? Okay. What do you guys get? I got 2 29ths. Yeah. At what point did you use our tangent? Oh, I mean, certainly could have. Yeah, I don't see an issue.
Yeah, I got 2 29s.
Okay, we all get 2 over 29? Do we plug it into our calculator? All right, I'm glad one person did. Thank you.
I don't have that.
Do you guys see where you're going to start getting bogged down by stuff? Yeah, Dalen.
Do you want it as a fraction or a decimal?
I mean, a fraction if it works out nicely. I don't really, I mean, this, because I input it as a fraction, it automatically spit out a fraction because it was quick and reducible. The previous one, even when you put it in as a fraction, gave you a very long decimal.
So like the 9 over 8 5, since there's 5, you want it to be decimal?
Preferably, yes. Or you can leave it as both. It doesn't, ultimately, it doesn't really matter. If you do use a decimal, it needs to be accurate to 3 decimal places.
Because aren't fractions typically more accurate because they're...
I prefer them. If you go into physics, though, you end up using decimals a lot. All right. Last problem. Potentially.
No. Bad. Yeah. Yeah, we're looking at, yeah, we're actually hooked on this one. Oh, because it can be reduced with calculus, but I don't think any of us have the tools.
Everything's good.
I have the
in
tools.
calculus.
Well, no shit, this is, they don't call it pre-calc.
Guys, if we work as a team, we can do this.
Yeah, I feel like it's easy to have calculus and still have a very solid understanding. I feel like if you even miss one class period, you're just kind of like in the dark for the next day. We have this class daily.
Just so you know, you dropped your gum. You guys see how the pictures correspond?
Yeah.
Okay, 3 is your crankshaft, right? 7 is this distance. X is here. Okay, when you find d theta dt, okay, I'm gonna tell you it's not just 200. If it's doing 200 revolutions, what also is a full revolution? 2 pi, right? So d theta dt is gonna be 200 times 2 pi.
That's actually good to know. It's just
Okay, is that the only given rate? Oh. You guys remember your law of cosines?
Nope.
Okay, well, because this is not a right triangle.
Well, cosine's adjacent to the hypotenuse would be 3 over.
Yeah, it's not. Okay. All right, real quick. So this is the given thing that they give us. They gave us this. Do we agree? That is our given information. Okay, what is it that we want to find?
Velocity at.
We want to find dx dt when theta is pi over 3 radians. Do we agree with that?
Yeah.
Okay, now the issue is we have to figure out, well, what formula, right, are we going to use here?
Give you one for velocity.
Okay, you have to use law of cosines. It's a triangle. Quit trying to make things, quit trying to like use velocity and all sorts of other stuff. Like, it is a triangle. We're gonna use some formula for a triangle. Does that make sense? Okay, the issue is it's not a right triangle. Okay, so we have to use law of cosines. And you guys are telling me that you don't remember law of cosines at all? Okay, so using law of cosines, okay? Because guys, the issue is, here's the issue. What is the title of this section called? Related rates. I have to find a formula that relates x and theta. That's the idea, right? We've been able to do it with Pythagorean theorem, right? Or using our trig on that last example, or doing area of a circle, because those things can relate, the radius to the volume, or the angle, right, to the height. The issue is this is not a right triangle, so we have to use law of cosines. So what law of cosine says, right, is 7 squared equals 3 squared plus x squared minus 2 times 3 times x cosine theta. Did you guys really not do law of sines and cosines in pre-calc?
Yeah.
Well, I know that's not true because we did it in honors algebra 2. Shortly.
I mean, it was like 2 or 3 years ago.
I mean, like, I can still have a pretty good grasp of the geometry from my freshman year, because all that is formulas.
Okay.
I don't know. No, I suppose trig is always kind of been a personal weakness. It's mostly just memorizing. I just like
So the idea, right, if I have this generic triangle, okay, it's always the side opposite the angle squared. A squared equals, okay? Then it's the other two sides. So b squared plus c squared. It's always, right? Kind of looks like Pythagorean theorem a little bit, okay? Minus 2 times these sides, the sides that are making up the angle, so 2 times B times C, cosine of that angle. That's where it's coming from. It's not like I just randomly made this up. Okay, so this is, let me lasso. Okay, so here's where this is, okay? What are we going to do now? Take the derivative with what? With respect to t. Okay, what's the derivative of 7 squared? 0. 3 squared. Okay, what about x squared? 2x dx dt. Right, remember this is minus 6x cosine theta now. Do we agree? What rule are we going to have to use there? Product rule, right? I'm going to pull the 6 out front, right? So that way all I am focusing on is x cosine theta. Are you guys with me? Okay, what is the derivative of x with respect to t? So I get dx dt times cosine theta plus, what is the derivative of cosine theta? Negative sine theta d theta dt, and what else is still included there? The x, right? So I'll put the x out front. We okay with that? So minus x sine. Okay. This looks super messy, yeah? Okay. So algebraically manipulate this because you want to get dx dt all by itself. Okay? You guys do that.
The biggest one is problem solving. It's like probably the primary one. Is what will you try to solve?
You distribute the 6.
I would want to.
Can I go to your mom? Sorry, I can't help much today.
You're good. She's not very much help when it comes to integration by parts.
Okay,
She doesn't know what it is.
that's fair.
So, have you ever seen Stranger Things?
What?
Have you ever seen Stranger Things?
Yeah.
In like season 1, 2, you're very Hopper-ness. Like Hopper in season 1 or 2.
Oh, is that what vibe I'm giving you at the moment? Okay.
Always.
Always perfect. Okay, algebraically that we should get this. And now we can substitute values in, correct? What are we plugging in for x?
Teaching right now?
Yeah.
I have one quick question. Was the homework in here? Or where was it?
Which homework?
You said we had asked you.
We had that bookwork. It was the bookwork, page 148 through 150.
Oh.
Or
okay.
no, sorry, not that. That's new bookwork, but the normal distribution work. It was assigned on Google Classroom. We
Okay.
worked on all day in class.
Oh, I finished that.
Okay. Okay, what's the value that you guys need to figure out? Okay, we're gonna pause here because we still have to figure out what x is.